Right under our feet lies an untapped source of energy. Clean, affordable, and abundant. But reaching it is hard work. Conditions are extreme, even life-threatening.
If it goes above the level, you just pass out, and if no one pulls you out of it, unfortunately you die.
But in Iceland and elsewhere, people are taking huge risks to bring us the energy of the future. In a world running out of fuel, the world's best engineers are figuring out how to power our cities using some ingenious methods. Solar, nuclear fusion, wind, and steam. This is a land where clouds rise from the ground and where trees are man-made. 70% of the power in this European nation comes from sources of energy that are clean and renewable. The chief source of energy is also unconventional. The tiny country of Iceland, on the edge of the North Atlantic, is the world leader in geothermal power. Geothermal plants take natural reservoirs of steam from deep underground and convert them to electricity. This plant opened just 2 years ago, yet work has begun to double its capacity. It's like building a whole new plant with whole new headaches.
Aber diagonale, only from the outside.
This is the drawing.
Huge headaches.
We won't get this crane back today.
Huge parts installed with outsized tools.
Tried it. It's so easy.
I love it. It's my favorite tool in the job.
Miles of pipes and sluice gates to control.
LDH 20.
Problems that baffle the brightest engineers.
Absolute null. But when pump number 1 was running, we had the full pressure on the suction side of the pump.
The extension to the plant must be ready in 6 months. But the severe weather here could wreck their timetable.
This builds up onto the profiles and breaks them. And we're not allowed to break it off because that, puts more pressure. We have to let it be. And this is what the wind, only the wind, did to a full column like this.
Most of all, to double the plant's capacity, they need to find twice as much steam.
We have an obligation to provide certain amount of power for the project as a whole, and we're now trying to establish enough steam for the new turbines.
In a small village in France, a pilot project is trying a whole new approach to geothermal power. There are no steam reservoirs here, so they have to drill deep into the Earth's crust till they hit hot rock, then add water to create steam.
First you have to hold on and to descrew it.
2 decades of research and work to reach a source of energy hidden 5,000 meters below the surface.
The last day, Peter. No,
It's not just groundbreaking, it's nerve-wracking.
Engine is running. Let's go! Water's leaking. More than before.
If it works, this plant could help wean the world off fossil fuels.
Stop it.
In Iceland, Marcus Fry enjoys having a green job.
Like, obviously, it's doing good for the planet, and it feels good when you do whatever you can, But I don't know, it's just something, it's clean power, and it sounded good.
Geologist Gretar Iversen knows geothermal power is not an exact science.
We are definitely gambling. It's very difficult to say about a well prior to drilling or prior to opening it up for the first time.
In France, Xavier Gerke has high hopes for the venture.
It's very interesting to make something new and to develop some technology to bring to a long living system.
and Jean-Paul Fat, experienced but still excited by the project.
Le moment excitant qui représente le plus l'aboutissement d'un long travail, c'est quand on arrive à avoir le nombre de kilowatts grimpés sur le compteur.
Winter in Iceland, yet construction has begun. Freezing temperatures and constant wind impede progress. Tens of thousands of parts have to be cut, assembled, welded, and adjusted. A gigantic jigsaw puzzle, and every piece must fit precisely.
10 millimeter over. Yes. Now. I need to have it back. Weld a piece here, so it won't go too far. 5 millimeter. Don't do anything foolish. Otherwise I will kick your ass.
At the foot of the mountain, Marcus races the clock to build a new cooling tower. He supervises dozens of workers, few of them from Iceland. Iceland is one of the world's most developed countries.
Very good. Dobre, dobre.
Yet among the most sparsely populated. With just 300,000 people, it suffers from a shortage of workers.
Yep, go ahead.
Marcus's crew come from Eastern Europe, where salaries are lower, but the work ethic is strong.
And the main thing with places like this is experience. Because these guys are working with us for the first time, like 80% of them. And we had to show them everything, just absolutely everything. I mean, a ratchet and a spanner, and where we use this. Because some of the guys use these as hammers, some of the guys, use this as open things.
What? How can this be?
They'll have to learn fast. In 6 months, the new generators must be ready to run. But the crew doesn't speak Icelandic. Some, not even English.
You take level, level? Uh-huh. Yeah, put level along. And then you can just get pen. They do understand basic English, but, it's very hard sometimes to explain something to them. Then we go get an English-speaking one, we tell him, and he translates. So we always find a way to do it. We can't let languages stop us. It's like the weather. If you let the weather control you, you're not going to be happy in Iceland.
Depending on the direction of the wind, steam can envelop Marcus's work site. Workers at the tops of the chimneys can't escape it.
Hvernig gengur det her? Allt I góðu? Vilja ná einhverju samræm og bandi líka, sko? These are the conditions we have to work in. You can imagine, like, I can barely see my colleague here next to me. So you can imagine if we're communicating and trying to work together. This gas, as comfortable as it can be, it's not more than that. It can be really annoying.
Not just annoying, steam can be deadly. Steam from the bowels of the earth keeps the plant alive, flowing through the pipes like blood through veins. Grettir Iversen is a kind of steam doctor. His job is to keep the plant in good health. Sodium in the steam corrodes metal. Grettir has to find it and eliminate it before it can damage the turbines. Another element in the steam is also harmful to life. Grettir can't see it, but he can smell it.
This is pure geothermal steam mixed with uncondensable gases like hydrogen sulfide, which is a poisonous gas. So yes, when I feel that the concentration is getting relatively high, I back a little bit away. If the concentrations go above 300-400 parts per million, then you would fall down and die. So it's a very poisonous gas, but if you know what to avoid, it's not a big problem.
Hydrogen sulfide smells like rotten eggs, but that's the least of its problems. Marcus and his crew are building the cooling towers, and today they work downwind. They can't escape the steam, so they carry a meter to warn them of danger.
This is our H2S gas reader, and it gives us a reading of how much gas there is in here. It's a sulfur. This is much more accurate, and if it starts making noises. It peeps, and if this reaches a level of 18, we have to leave the site, because people start passing out, because you can't really smell it once it goes past a certain level. Like when you drive into the area, you can smell a bit of a smell, and that's maybe a level 2 or 3. Here, it's okay for us to work 8 hours in about level 15. If it goes above 15, we just have to go.
The level is creeping up toward the danger zone.
There's no oxygen inside this gas. It travels in pockets, and if this pocket comes around you and sits maybe around your head, you take one breath, you pass out, and if no one pulls you out of it, unfortunately you die. That's why every time you're doing something, you stay 2. So always someone to back you up. But if you both pass out, I hope you have a nice trip to heaven.
The land of ice is also the land of heat. Rising from the Earth's crust, the ground steams, sizzles, and bubbles. Iceland is one of the most volcanically active regions on Earth.
We are standing in the middle of the western Icelandic volcanic zone, and you see certain surface manifestations like eruptive fissures. To the sides, both east and west of us, we have an older area which used to be in the middle of the rift zone, but has since drifted east and west.
The mid-Atlantic rift between the American and European continental plates is one long chain of active underwater volcanoes. In the north, they surface and traverse Iceland, which itself straddles the 2 plates as they move apart. The rift has left a huge scar. On the right is Europe, on the left, America. Once a ski station, it's been transformed into something much more profitable. The surrounding land gets plenty of rain, about 30 inches a year, and the rain seeps down to the hot rocks. Heat and water, the ingredients of steam. Gredar is hunting for more steam to feed the expanding plant. But each zone he inspects is not only different, it's constantly changing. Gredar and his crew never stop collecting data. They use maps of underground activity to help decide where to drill. They use the global positioning system to pinpoint possible sites. From there, Gredar uses his gut.
Ten years ago, we had a massive earthquake which lasted for 4 years, and the area rose by 20 or 30 centimeters. This was due to a magmatic intrusion at 7 kilometers depth below us. So sampling the surface fumaroles gives us an indication of whether this magma is reaching the surface or not. We measure the temperature of the springs and the pools. We measure the pH, the acidity. Other things we do is we sample the gas coming from these springs and these fumaroles. The composition of the gas, the concentrations of certain constituents in the gas give us a direct indication of the temperature in the geothermal reservoir beneath us. So by sampling the surface gas, we can map the subsurface reservoir, and we can have a better understanding and a better idea where to drill if the area would be developed in the future.
volcanic regions, where fire and water are abundant, all you need to do is drill down about 6,000 to 9,000 feet to find steam at almost 500 degrees Fahrenheit. The steam flows from the wells through large pipes to the plant. Then the steam is cleaned of impurities before reaching its final destination, the turbine. The steam turns the turbine to power an electric generator. The Italians pioneered electricity from steam more than a century ago, and it still works the same way. At the turbine's exit, a curtain of cold water forms a depression that accelerates the steam and improves the turbine's output. This part is called a condenser. The condenser is linked underground to a cooling tower. Inside, pumps carry the water to the top, where it's dispersed by huge fans. On the way down, water hits the air, cools, and returns to the condenser. Although it sits apart from the main producing machinery, the cooling tower is an essential part of the plant. Tower number 4 still awaits its chimneys. Each is the size of a school bus and weighs as much as a grand piano.
Yeah, it must be this
To lift them, they rented one of the biggest cranes in the country, but it's gone. Rush to an emergency elsewhere on the site.
This is just terrible. We won't get this crane back today. We'll just have to lift them tomorrow.
Start lifting it when the crane is coming over your finish. If it's by 5 o'clock, you can lift one ring.
Yeah, I doubt it though. Set up the crane, lift it in, probably fasten it. So annoying. God.
Nothing can happen till they get the crane back. As suddenly as it vanished, it's back.
This crane is such a little... I know it'll handle it, but look at it. It's standing on 4 legs on 4 little pieces of wood. It should be, yes, but it's just, you know...
It's one of the biggest cranes in the country. It weighs 80 tons and has a 120-foot arm. So long, the crane operator can't see what he's doing and needs to be guided.
Har det en slack, okej?
Go. Slaka örlítið á því. Stop.
Communication is very important with the crane driver. You know, if he goes down too fast, then, like you see, this could break, this floor, for instance. It just has to be exactly level. And you can see how close it is, the cut here. And see, it's like half a centimeter, not even, a few millimeters here. So this is very precise.
The crane operator has to set the chimney to within 1/4 of an inch. Then the crew must align it to a fraction of that.
Maður hana? Ég að tala við þig, þú ert maður.
All the while, the crane stands by in case they need a lift. And the meter's running.
For rental, it's 500 euros up to 1,000 euros per hour. We don't think about, you know, the expensive crane. We just want to do the job good. But we try to adjust it as good as possible now, and later on we use special tools to finalize the adjustment.
No special tools here, just brute force. But it's not enough. This rig will make the final adjustments. By the end of the day, all 4 chimneys are in place.
Now I can get rid of the expensive crane. And I had the líka betur.
They still have to assemble the fans. And there's bad bad news. The forecast says a storm is brewing. Iceland is the Saudi Arabia of steam. This area contains some of the most productive steam wells in the world, with huge reserves, enough to power the whole country indefinitely. But two wells side by side may produce far different amounts of steam. Deciding which wells to tap is the job of scientists like Gredar.
We are definitely gambling. It's very difficult to say about a well prior to drilling or prior to opening it up for the first time. You need a lot of steam. Sometimes you find very good quality steam, but there's not enough of it. Generally speaking, in this area, you need just over 2 kilos of steam per second to produce each megawatt of electricity. These wells are probably producing some 17, 18 kilos of steam per second. And that's enough to produce 8 or even 9 megawatts of electricity. So these are extremely good, and we're very happy about them.
Geothermal electricity has made Iceland the richest country per capita in all of Europe. This gift from the earth seems inexhaustible. So long as they tap the right wells, they can power the new turbines for the plant.
So we're eager to find enough steam, and I think we've made it now. So we have more than enough at the moment.
With active volcanoes and plenty of rain, Iceland is made for geothermal power. But geothermal energy is everywhere, if you dig deep enough. Far from any volcanoes, in a French village just a few miles from the German border, an international team is developing a new type of geothermal technology. It's a pilot project funded by a European consortium, 20 years in the making. Iceland inspired the idea, but the team had to invent the solution. The plant opened just 3 months ago, but the team has to constantly adapt to surprises. At this moment, the plant is shut down for repairs.
Yes. First you have to hold on and to descrew it.
Yes.
This one is okay.
Yes,
Polo supervises the repair, assisted by his right-hand man, Xavier. Advising the team is Peter, a mechanic from Iceland.
Wrong to find the wrong. I think it's okay.
His English is shaky, but his advice is priceless.
Voilà, ça tourne à gauche. Non, c'est dans le mauvais sens. Dans le mauvais sens, c'est pas grave.
The team is using a pump from Iceland, and it hasn't stood up to local conditions. A far cry from Iceland. In Iceland, geologists create maps of underground activity, then decide where to drill. Giant steel drills rattle the ground 24 hours a day. At depths of around 6,000 feet, the drills reach reservoirs of steam at 500 degrees Fahrenheit. This is the raw material that flows up the well and through pipes to the plant, where it's transformed into electricity. Rain will come sooner or later to renew the reservoirs of steam. To hit 500-degree rock here in France, they have to drill down nearly 15,000 feet, twice as deep as in Iceland. The rock down there is dry, so they have to sink 2 shafts, one to inject water to produce steam, another to pump the steam up. When the steam leaves the power plant, it's converted back into water and pumped back into the well. The French inject the well with local water, some of the saltiest water in the world. In fact, the village here is called Sulz, salt in the local dialect. Salt has eaten away at the steel pump and put everybody back to work. Breakdowns like this don't happen in Iceland, where the water's so pure you could bottle it.
Because of the high salinity of the water and the number of particles which were on the water, we damaged the inlet of the pump. It's coming from Iceland, and in Iceland the water is less mineralized than ours. And we are now looking for a new metallurgy of the pump.
One more time.
So we have to find materials which can support this type of water. And it's not so easy to find.
Yeah, I think it was corrosion. Hit it up.
They need to find a new pump that will resist corrosion. In the meantime, they jerry-rig a repair and put the pump back in place.
Now it's just for waiting. We have some tests to do, and we assume that this pump with the old metallurgy will last not so much time, but enough to make the test we want. And after we put everything out and change the pump itself.
On a normal day, they could lay 15 to 20 sections of pipe. Today, anxious to finish the repair, they laid 25.
We were as speed as we can, and we did a good job today. Very good job.
The last day, Peter. No.
Peter is persuasive.
This is really the last one. After that, we wouldn't see him.
With a second wind and the urge to get to bed, they lay the last pipe in record time.
Very good. In my head, very good, and in my muscle, it will go. If it lasts so until Friday, it will be good. But we can manage it. It's okay. Seems to be very good.
On Monday, they'll test the repair and find a whole new setback. Iceland is bracing for a big storm. At Hellescheide, Marcus's crew races to install the fans for the cooling towers.
That was good.
The blades turn at more than 60 miles per hour, so they need to be firmly anchored.
Tiny. It's so easy.
With this lovely little tool here. Like a climber.
To tighten the bolts, an ordinary wrench won't do.
I love it. My favorite tool in the job. It's really hard. I don't know, the average bolt tightening is maybe like 10 Newton meters. This has to be 1200. It's crazy. Yeah, well, it's heavy. I'm just scared of dropping the key.
Marcus has to push till he hears the telltale click.
That's it's reached the level that we wanted. It's reached what, 1160, isn't it? Yeah. 1180. That means that we've reached the full pressure. Thank God.
They have to repeat the ordeal dozens of times for each fan.
It's the Iceland's strongest people. Oh, yes, finished. It's only one fan. We have 3 left.
When rain hits the site, it creates haves and have-nots. The welders have shelter. They can't weld in the rain. The have-nots are exposed to the elements. Marcus is a have-not. Inside the chimneys, at least, he has shelter from the wind. A visitor has brought the extreme weather, Tropical Storm Bertha, probably the only tropical thing you'll find in Iceland. To precisely angle the fan blades, they'll use a giant level, but it's not made for this weather.
It's a problem when we don't have waterproof tools. People buy non-waterproof tools to bring to the wettest area in the country. So now we have to put plastic over it, seal it, and now we can hardly see through the plastic. It makes everything slippery, and now I'm wet all the way up here because I'm always like this. The water goes down. It's, you know, it's fun working in the rain, that's what you say. But this is what I get paid for.
Helping Marcus is a student on summer break. As the bolts are tightened, she checks the angle of each blade for best performance.
7.9 degrees is perfect. And we're only allowed to have 7.9 or 7.8 or 8. We cannot have anything else, and that's, you know how hard it is to move this? Like 0.1? It's crazy.
For such precise work, the little student needs a boost.
Herra Frekja. Nej, du tar tacka till. Sorry, we just started trying to get the box because our staff is so small, she can't see up on the fan blades. So always some weird problems like this. On the blood. Okay.
She announces any movement in the blade's angle, down to the fraction of a degree.
Oh yeah, 7 point. Sorry? How much? Det är bara mumpel.
Ja, är vi fler?
Jag säger vanskligt. Okay.
Maybe she needs one more tool, like a megaphone.
9, 0, 8, 7.9.
Uli is Marcus's boss. He's German, but he's been working in Iceland for 15 years. He's a world expert on building cooling towers, yet building his reputation took sacrifice.
I see my family 3 months in a year. Yeah, I'm married with my job. My wife is second. Sorry to say, but it's so. It's true. It's true.
This year, his son is working with him. Pocket money for Stephen, and good company for his dad.
He wants to make his driving license. He wants to have a car later on, and I told him, okay, I help you. You can work here. You can make money for your driving license, and we are together the whole time. It's 3-2, but check it.
But the boss's son doesn't get special treatment.
Normal 3-2. Is it 3-2 or 2-2? 2-2. Okay. 7, 9, hey, raus. Was willst du denn da? Wie soll ich den hochheben können? Nehmt euer Gehirn. Ja, sicher. 2-2.
The boss's mood is as foul as the weather. Snow would be easier to work in.
This is different, because this is rain, this is wet, and the wind is so strong at the moment. This is more like a storm, you know, it's very strong winds coming and going, and in winter it's more steady. You know, it's, I don't know, it's just different. We're not used to this.
The weather wins. The rest of the fans are grounded, too fragile to be buffeted in this wind.
Usually if it was something bigger, we could probably lift it. Because these are so delicate, we don't want to take the chance. So we all find little things we can do, but it's a shame because we need to carry on with the fan blades, but what's one day? We're ahead of schedule, I hope so.
Ahead lies another setback for another crew. At the pilot plant in France, the repaired pump is ready for testing. Polo and Xavier are like expectant fathers, proud and nervous.
We are a bit stressed because we have a lot of parameters to work on and to be sure that every stage is running very well, to increase progressively the flow, to decrease the flow, to be sure that the pump is running well.
It's a good start.
Polo is ready.
C'est
Let's
parti!
go.
Pressure mounts. The engineers stand in the
Ça, c'est l'artésien.
The repair of the pump is the Achilles
L'artésien
heel of the
séparateur
whole
GP2.
system.
Et ça, c'est dans mes
Engineers
cubeurs.
constantly monitor the output and pressure. All goes well until Xavier detects an anomaly.
Water's leaking. More than before.
The indicators are in the red.
Now, if we go over 40%, you stop it.
No choice but to stop the pump and the test. One of the pump's seals has failed. A small glitch with a big impact. For the pump to bring up steam, the pipe has to be airtight, but a seal is leaking. As a result, they can't reach the pressure they need.
In the office, everybody is working because one ring had broken and we have to change it, and it's not so easy. And to change this ring, we have to have no pressure inside the hole, and so we have to decrease this pressure by injecting some salt water. So it needs time and money to be done. So it's not so easy to make geothermal.
To replace the faulty seal, they have to lower the water level. They call it killing the well. They do it by adding salt to increase the water's density. For once, their everyday enemy becomes an ally. The faulty pump cost days of delay. One week later, they're ready to try again. Once more, hope returns.
Pressure goes to the exchanger, filter one gets water. We have pressure inside. Engine's running, everything's ready.
Everyone is back in place. Polo at the controls and Xavier at the command post. More adjustments and more tension.
I opened filter one's pressure sensors. Do you see something? Is it still going up?
Écoute, on a toujours 4 barres dans l'annulaire.
At last, the pressure rises and steam flows through the pump.
Now we will be able to produce electricity. With the flow we have on this pump, we are able to produce electricity. We are proud of what we do now. We are a bit stressed because there is a lot of risk and of pressure on the crew to do it, but we are very proud of what we do now.
You don't have to search for geothermal power. You can make it.
On l'a déjà fait, mais sur une très courte période. Nous, ce qu'on envisage, c'est de le faire sur une longue, très longue période. C'est-à-dire fournir à l'habitant de l'énergie électrique via la géothermie des rôles profonds.
If Salts works, it'll power more than a village. It will fuel hope for geothermal power to one day supply the world. In Iceland, Tropical Storm Bertha has moved on. Every morning at 7:30, Marcus arrives from Reykjavik. One morning ritual is as important as his coffee. Playtime with Bruno.
No, there's no requirement, but since I put it on him first, they sort of ask me to now, because they know that he has a vest. Before that, they didn't even know they had dog vests. Mr. Hada. Tageda. Huh. Since he was 3 months old, he's been living in the car with me on work sites, so everyone here knows him, and he's a really good safety feature also for our company. Because like when we're around the cooling towers, he knows that's our area. So if we have a different company coming in wearing a different uniform, he barks at them and lets us know straight away. He's such a good dog. As you can see the mountains here behind me, that's his playground, and there's very few dogs that get a life like he does. For 12 hours a day, he gets to just basically run free, and I think he's the happiest dog around. I mean, not to mention how much I spoil him.
Marcus's contract began last winter, when boiling water kept the foundations of tower number 4 from freezing. Tower number 3 was just a skeleton, and the crew was still green. Yet soon they overtook their own schedule.
Well, the estimated time for a tower, I think, according to the contract, is about 5 to 6 months. Like the first tower took us maybe 5 months. Now we're making a tower in about 3 months. But don't tell the contractor that.
Working like acrobats in the wind and rain, they erected the towers without a single calamity.
We have been actually very lucky. There have been no serious accidents. People have actually just crushed their hands, broken 2 fingers. That's about the worst that's happened here. We've been very lucky, and we've built so far 7 cooling towers here.
The 4 towers that Marcus worked on this year are all complete. Now the challenges move indoors. Inside the plant, workers apply final touches and run the last tests before the turbines are turned on. With the startup looming, trouble.
Und die fährt 0.
German engineers from the company that installed the condenser detect a problem in the maze of pipes. One of the pumps that carries water to the cooling tower isn't working.
Okay, wir fahren nochmal die Pumpe 1 hin. We are starting here a cooling circuit, a small circuit with 2 parallel pumps. They are working absolutely parallel and only one pump should work. Now we have tried it on that side. This pump is working correctly and makes a pressure of around 1.5 bars. That should be when the pump is working. And here, this pump makes a pressure of 0. That means no water is flowing, although it is absolutely parallel. And we are assuming that something is wrong here in the suction side.
No suction, no power. Somewhere in this maze lies the tiny problem that shut down the whole plant.
Okay, 0, absolute 0. But when pump number 1 was running, we had the full pressure on the suction side of the pump. So during that
The plant drafts every engineer to solve the mystery.
We start now pump number 1. We open the suction valve, start the pump, look to the pressure. Then we do the same on this side. And afterwards, when it has no pressure, they have to open the pipeline.
As a last resort, they decide to open the pipe itself and examine the suction valve that's vexing the engineer.
Okay, Dieter, bitte das Ventil LDH20, AA021.
But the valve seems to be working fine. The mystery remains.
Can it be blocked? Let's try it. Okay, we have seen it's working correctly, or better, yes. Let's build it in.
With no more ideas, they put the valve back and try again.
Okay, jetzt ist der Druck da. Here, look. Now we have the pressure. This damn valve needs a kick.
There was a lot of ghosts in this area.
Maybe. But now we have the pressure, all things are okay. The problem was that maybe something has forced this flap into closed position. And now, when we have opened it, had it moved sometimes a little bit, it has gone now in open position. It's now running well. Okay, it's running well, fine. Okay.
Nearby, a familiar face, still working up high, but not in the towers.
I'm on holiday. No, it's all finished out there, so you know, there's no need for me until the next towers come up. So basically, I just got assigned to a different job. They asked me where I'd like to go, and well, the day they asked me, it was really bad weather outside, so I chose to come inside. And ever since then, it's been sunny outside. So, but this is fine. I'll be painting for like 1 week. It's good to have a break also from the cooling towers. I've been doing them for like 2.5 years now. It's quite nice just to do something different, and you know. So I'm guessing in about a year's time, I'll be ready to get back into the cooling towers. Until then, it's just nice being relaxing. I mean, I could go on holiday, you know, without pay, of course, for a year and just come back. But, yeah, we'll just see. I haven't really decided. That's the exciting part, I think. There's nothing planned. I mean, as long as I have a job and everything's okay, I'm happy. So now I'm just like the handyman. It's a different job to that. I don't have to talk and be responsible to anyone. It's quite nice.
Right on schedule, thanks partly to Marcus. The new generators fire up. In less than a year, the young plant has doubled its output. Year by year, geothermal power plays a bigger role in producing electricity, and the plant at Hellescheide takes Iceland one step nearer its goal, to become the first country with no need for coal or oil. Iceland inspires other nations to tap their natural gifts: wind, waves, sun. Energy as clean as it is endless. Geologists have mapped another huge steam reservoir at Hellescheide, enough to double its output again. One slight problem: the pipes are already as tangled as they can get, so the factory can't expand. They'll have to build another plant right next door.